great video on the heavy duty oil stabilizer. Now, how to use it? I mentioned that you're going to use it at 20% to the volume. So let's break that down, what that exactly means. We replace 20% of the lubricating oil that's being used. So if an engine normally uses 10 liters of oil, ProOne engine uses 8 liters of its oil, and then we add 2 liters of the ProOne heavy duty stabilizer. So out of 10, you're taking 2 out, going to add 8 of your base oil, and then to make up the 10, you have 2 more, and you add the ProOne heavy duty oil stabilizer. And it's added each time to every oil change. You measure the effectiveness through oil analysis. So you do want to take an oil analysis when you're getting close to your normal change interval, so you can see the before and after. This is very, very important. Okay. So with the heavy duty oil stabilizer, the wear metals you're going to see are greatly reduced. Now I have an analysis I'm going to show you in just a minute, and that will show the oil remaining usable. We're going to usually reduce wear metals by 50%. And so we're going to extend the time between these oil changes, and you're going to observe the reduction in noise and vibration. These are some of the benefits. So let's take a look at what those results look like. Now this particular engine in the vehicle that it was in is severe duty. It's off-road. It's in a concrete application where lime and dust and just tearing up this engine. So look at the numbers that's happening here. I'm going to explain this to you in just a moment, but the following data was obtained from a construction company and was notified that they had to take immediate action through this oil analysis test on their Cummins engine due to high levels of iron and chrome and lead and aluminum and soot. They had a lot of wear that was there. So after adding the ProOne heavy duty stabilizer, their wear metals dramatically decreased, saving this engine and giving them some added performance. So let's do a little bit of highlighting here. The copper, which is the CU, this is where bushing and bearings are. So what we did is we took that from 135 parts per million, the ppm, to 20 parts per million. So that's what happened here from here to here. This Fe is in iron. And then, so this is cylinders and rings and crankshafts. We took this one from 431 parts per million to 68 parts per million. And then the aluminum this is in pistons and bearings and pumps. We took that from 9 parts per million down to 2. All right, so what is the actual reduction? It's 85% reduction in copper, 84% reduction in iron, and 77% reduction in aluminum. These, I will tell you, is not necessarily normal, but we do this in extreme, heavy-duty, severe applications. So, again, copper, iron, chrome, and aluminum. And when you look at these, now, what we have here is a 3, but we're taking these and reducing them dramatically. This is what they were before on a severe duty application, and then we reduced to these very low numbers. And yes, the account was very, very surprised in its results, and the engine continues to operate.